Assalamualaikum. So today we are going into linear equation. Alright. So I just want to give a short note, okay, an extra note for you guys. Alright. And then you get, because inside this note we already have the notes, right? But this one is just an extra note. So linear equations. So when we are talking about linear equations, alright, the definition of linear equation is, so we have the differential equation. Differential equation of ax dy over dx plus bx y is equal to cx. Okay, so where our ax, bx and cx are continuous function of x. Okay, or a constant. So this one is called first order linear equation. First order linear equation. Okay, so this is the general equation. Alright. Alright. So let's see the method of solution. Okay, so we have the general equations. So this is the first one. So now we are going to rearrange our first equation. Okay, we rearrange our first equation. So when we rearrange, okay, because we want to make the coefficient of dy over dx is equal to 1. Right, so we will have plus this one. Okay, for linear equation, alright, for linear equation, the coefficient of dy over dx must be 1. Okay, must be 1. Then so we replace bx over ax with bx and cx over ax with qx. Okay, so this is our second equation. Alright. Then we setting integrating factor. We set an integrating factor where we let rho is equal to exponent of integrate px dx. Okay, So this is our third equation. Then we are going to differentiate our third equation. So when we differentiate, so we're gonna get differentiate with respect to x. So d dx exponent of the grade px dx. Okay. Alright. So this one will become d dx, and then integrate px dx. Okay. Right. So this one will be px and then rho. Okay, so this is our fourth equation. Alright, next we are going to multiply our second equation with rho for both sides. Okay, both sides. So you're gonna get rho dy over dx plus with rho pxy, and then it's equal to rho qx. Okay. Fifth equation. Then then can be written as so become this one become d dx rho y is equal to rho qx. Okay, is equal to rho qx. Okay, then we integrate both sides. Okay, so then we integrate both sides. So this is our sixth equation. So we integrate d dx y dx QX dx. Alright, so this one become now we will have rho y is equal to integrate rho qx dx plus with c, and you get your general solution as y is equal to 1 over rho p, 1 over rho, and then integrate rho qx dx plus with c. Okay, so basically this is the method of solution for linear equation. Okay, so the summary of this one is here. Okay, is here. Okay, now we will go to this one. If you want to understand on how we get this one, so you should refer to my notes. Okay, so for linear equations, okay, so this is the general form of linear. Okay, linear DE. So the first one that you need to make sure is, okay, the coefficient of dy over dx must equal to 1. Okay, must equal to 1. Then the second thing is this sign must be positive. Alright, this sign must be positive. So let's say you have minus here. So meaning that the value of minus comes from the values of px. Okay, from px. So the coefficient of y here is your px, and then right here is your qx. Okay, alright. So first thing first, okay, the method of solution is you need to determine the value of px and also qx. Okay, determine the value of px and also qx, and then the coefficient of dy over dx must equal to 1. This one you need to make sure. Okay, this one you need to make sure. Alright, next you need to find the integrating factor of mu x, where the notes up there I use rho. Okay, so here we use mu. Okay, so the integrating factor, the formula is mu x is equal to e integrate of px dx. Okay, once you recognize what is your px, so you can find your integrating factor, where e integrate px dx. Alright, then what you need to do next is you need to do d dx mu xy. So mu xy, so here you obtain your mu x, so you can find this one mu xy, and then over here is mu xqx. Okay, so to find mu xy, so we just rearrange the equation and become like this. Okay, and then we want to find the general solution, so we'll let y to be the subject. So once y to be the subject, so this is the general solution of the linear equation. Okay, alright, simple, right? Okay, so now let's see example. Okay, so for the first example here, okay, they give you this equation. Okay, first thing first, okay, if you want to make sure that this question is the equation is linear or homogeneous or separable, first thing first, you need to if you want to confirm that this one is a linear equation, first the coefficient of dy over dx must equal to 1. Okay, and then the coefficient of y here must be your px, and then over here is your qx. Okay, so first step, okay, you need to determine what is your px and also your qx. So here px is equal to this one. You need to write this one. Okay, you need to write this one because that's marked for this one. Okay, so px is equal to this one, and then qx is equal to this one. So this one. Alright, next, after you able to determine what is the px and also the qx, so next you need to find the integrating factor. So this is the formula of integrating factor, where mu x is equal to e integrate px dx. So mu, to find mu, E, integrate. So this is your Px. Okay, Px. So Px is 1 over x plus 1. So 1 over x plus with 1. Okay, so this is 1 over x plus with 1. Alright. So integrate 1 over x plus with 1. So you obtain ln x plus with x. So this is law of exponent. So you're gonna get E with ln will be cancelled out. So become x ex. Okay, so mu x is equal to x ex. Next, after you find the integrating factor, so you need to write the equation. This one, d dx mu y is equal to mu q. Okay, so your mu is equal to this one, so substitute here. And then y, and then substitute mu here. So become this one, and then your qx. Okay, so you solve this one. So once you solve, so you get this one plus with c. Okay, so we want the general solution, so make y as your subject. Okay, because general solution means that you want to make y as your subject. So this is your final answer. So since these questions does not give you the initial solutions, so meaning that your final answer will have the constancy. Okay, constancy. Alright? Simple, right? Okay. Or you may write your answer like this, or like this also can, both accepted. Okay? Alright. So there's some note over there. So if the equation is a non-linear, okay, we can convert the non-linear equation to become linear DE with the right substitution. Okay, same goes to the separable, homogeneous. If in the beginning the equation is not separable, not homogeneous, and we want to make it separable and want to make it homogeneous, same thing here, we need to use the right substitution. Okay, so now let's see example of using substitution. Okay, so using z is equal to y squared. So don't worry here, the question will give you the substitution to use. Okay, so in this example, they ask you to use z is equal to y squared. So convert the following non-linear DE into linear DE. So given here, this one is a non-linear DE. Why? First thing first, alright, the coefficient of dy over dx here is not equal to 1. Okay, it's not equal to 1. Okay, so once you have the right substitution, z is equal to y squared. So what you need to do first is you need to differentiate. Okay, differentiate this one with respect to x for both sides. So dz dx. So this one differentiate with respect to x. So become 2y dy over dx. Okay, 2y dy over dx. So make dy over dx as your subject. So we will get this one. Okay, we will get this one. So once you get dy over dx, okay, so this is your questions. So now you need to substitute dy over dx over here. Okay, so once you substitute, so you will get like this. Okay, you will get like this. So for linear equation, you need to make sure that the coefficient of dz over dx over here must equal to 1. Okay, must equal to 1. So you need to modify this equation and become like this. Okay, and become like this. So now the coefficient of this one is equal to 1, but then here is minus. So meaning that your value of Px is equal to negative 2 over x, because the general solution of linear equation, this one is plus. Okay, so you need to be careful here. If this one is minus, so meaning that your value of Px is minus, is negative values. Okay, And then your QX is equal to 2 over X squared. 2 over X squared. Okay. Once you're able to determine your PX and also your QX, so this one determine your PX and then your QX. So then you need to find your integrating factor, which is mu x is equal to E integrate PX dx. So your PX just now is equal to negative 2x. So you just substitute here. So integrate that one. So become E negative 2 ln x. Okay, so by using the law of ln, so you get ln x over ln x power of negative 2. So E with ln can be cancelled out. So now become your mu is equal to this one, 1 over x squared. Okay. Alright, next. Now we want to find y. Okay, we want to find the general solution of y. So you need to do this one. D dx mu z is equal to mu q. Okay, so just now you already find your mu. So mu is equal to 1 over x squared. So substitute it here. And then your value of q, substitute it here. Okay. Then, okay, d dx here, you bring to another side, so become integrate. Alright, so you solve this one. Alright, and then make z as your subject. Alright, make z as your subject. So once you make z as your subject, okay, don't forget that you are using substitution just now. So you cannot let your final answer to be in terms of z. Okay, you need to substitute back what is the value of z. So z is equal to y squared. So substitute it here back. Okay. So once you substitute, so become our solution become y squared is equal to negative 2 over 3x plus with cx squared. Okay. So given in the questions, they give you the initial condition where y1 is equal to 1. So if they give you the initial condition, so meaning that you need to find the value of c here. Okay, so now we are going to find the value of c, so where your x is equal to 1 and your y is equal to 1. Okay, so now we obtain your value of c is equal to 5 over 3. So your final answer will become this one. Okay, substitute 5 over 3 inside c here. So your final answer become this one. So even though here we have y squared, it's okay. Alright, it's okay. If you want to let your answer to be y squared is equal to this one also can. Or you want to bring the square over to the right hand side also can. So become square root if you want to let y is equal to this one. Okay, so this is the solution for this example. Alright, for this example. So basically, there's two type of example. The first one is without using the substitution, and the next one is by using the substitution. So here we go. We have questions from past year for test 1. So please try these equations. Alright, these questions 1, 2 and 3 as your exercise. Okay, so thank you.